Hello everyone, myself Professor Chavan. We have started the third chapter from our 11th Science CBSE board for the subject physics. In previous lecture we have learnt about the two quantities, that is the speed and velocity. How these two quantities are differentiated from each other, which specifications we have to consider for their differentiation, and which are the specifications which make them to consider as the one single quantity. But they are not the single quantities, they are the different physical quantities. Okay, and we have differentiated in based on some specifications. Okay, now if we consider it in our numerical point of view, then if we have to calculate the distance, or if we have to calculate the speed of a minute hand from of a clock from 6 p.m. to 6:45 p.m., then in that case, how can we calculate its speed and how can we calculate its velocity? Okay, how can we calculate its speed and how can we calculate its velocity? So suppose if this is the clock, okay, this is the 6 p.m. and from 6 p.m. it has to come up to the 6:45. Okay, it will be 9, 3, 6, 12. This is the hour hand. Okay, so your minute hand is traveling from this place to this place. Okay, so during this, how much is the distance covered by that minute hand? We have to calculate this if we have to calculate the speed. Okay, so how can we calculate the speed in this case? The speed is equal to distance upon time. Okay, so in this case, how much is the distance? What is the total distance covered when it completes the one rotation? We have to consider the 3/4 part of it. Okay, so total distance covered will be 2 pi r into the 3/4. Okay, that much amount of will be the distance. Now, how much is the time? It is 45 minutes. We have to convert it into the seconds. So 45 into 60. Okay, how much is the speed? Speed will come as the, how much it is coming here. If we take the considerations, we come to know that here it is 1, 2, it will be 3 pi r upon 45 into 120. It is having the meter per second. So it is 3 pi r into 45 upon 120. That much amount of speed will that minute hand will have when it travels from 6 to 6:45 p.m. Okay, 6 to 6:45 here, 6 to 6:45, 6 p.m. to 6:45 p.m. So the minutes taken is equal to 45 minutes. Okay, and the distance, it will be traveled length it will be equal to 2 pi r into 3/4. Okay, 3/4 of 2 pi r. Total circumference of this total circle into the 3/4. That will be the total distance traveled by the minute hand. Okay, so by this way we can calculate its speed. Now what if we have to calculate its velocity? We know velocity we can calculate only if we consider the distance traveled in a straight line, and we have to find out the distance from the initial position to the final position. Okay, so from in this, if we have to calculate the velocity, we have to consider this straight line distance. We have to calculate this straight line distance, and after calculating this straight line distance, we can go for the calculation of a velocity. Okay, so if we consider this is having the r length of the minute hand and the r, then velocity will be equal to displacement. How can we calculate the displacement here? How much is this distance? It is nothing but equal to one right angle triangle we have to consider here. So if we consider here one right angle triangle, then in that case, how much is this total distance? It is the one hypotenuse. So this total distance will be the 2 pi under root of r. Okay, it will be under root of r square plus r square. And how much is the time? Time taken will be 45 into 60. Okay, so it will be under root of 2 r square upon 45 upon 60. So if we get here r under root of 2 upon 45 into 60. Okay. So if we look at these two terms, we come to know that the velocity is less than the speed. Okay. The velocity is less than the speed because here if we consider, then it is 3 pi r upon 45 into 120, but here it is r into under root 2 upon 45 into 60. So it will be meter per second. So this value will come automatically less than this speed, and our differentiation point will get covered there, that the speed value of the speed is always greater than or equal to the velocity. Okay, it is always greater than or equal to the velocity. Now if we consider the one revolution of Earth, okay, so during the revolution of Earth, how much will be the velocity of Earth for the 24 hours? Okay, for the time period of 24 hours, how much will be the velocity of? Okay, for the 24 hours, the Earth revolves around one circle. Okay, Earth revolves around one circle. So from this point, after 12 hours, the Earth will be here. Okay, and after 12 hours, Earth will be here. So it will be initial and the final position. So if we have to calculate the velocity of Earth after 24 hours of time period, then if we think about the initial and final position of the Earth, it will be same. So if we have to calculate the displacement of the Earth after the 24 hours, it will be 0. Okay, the displacement will be 0 because here this initial and final positions are same. But if we have to calculate the speed of the Earth for the 24 hours, then can we calculate the speed of Earth? Yes, we can calculate the speed of Earth. The Earth revolves in a circular orbit. Okay, Earth revolves in a circular orbit, and for that purpose, whatever the distance covered by the Earth, it will be equal to the circumference of that circular orbit. Okay, the distance will be equal to the circumference of that circular orbit, and then we have to divide it by 24 into 60 into 60. Okay, how can we calculate the distance covered by the Earth? We have to know the radius of that circular orbit. Once we know the radius of the circular orbit, we have the time period. Okay, so we can calculate the speed of the Earth by speed is equal to distance upon time. So it will be distance is 2 pi into the radius of the circular orbit upon 24 into 60 into 60. We have to convert this into the second. Okay, so we will get the speed of the Earth. Okay, so by this way we can calculate the speed and velocity of the any object if we have to know its speed and velocity. Okay, so the next point we will see, it is about the average speed. How to calculate the average speed? Okay, we have to see the average speed and the numericals on the average speed. Okay, simple numericals are there. just the two conditions are there in the average speed. Okay, average speed so why there is a need to calculate the average speed? Suppose we have to travel for 100 km within the 2 hours. Okay, suppose there are the 2 points from this point to this point. If this distance is the 100 km, okay, and for this purpose we have the 2 hours. Okay, then for these 2 hours, how much will be our speed? How much will be our speed? We can calculate easily. We have the distance, we have the time. Okay, we have the distance, we have this time. From this, the speed is equal to distance upon time, 100 upon 2, so it will be 50 km per hour. Okay, 50 km per hour will be the speed of our vehicle when we have to travel from this point to this point. Okay, but what if during this time, if there is some obstructions, like if there is some marketplace, or if there is any village, or if there is any school area, then what we have to do? We have to reduce our speed, and we cannot go with a constant speed of 50 km per hour. We have to reduce our speed. Okay, so whenever there is a crowded area, we have to reduce our speed for that particular small distance. Suppose that small distance is a delta S. Okay, delta S is the small distance. Okay, and let the delta T be the time period to cover this small distance. Then in that case, how we can calculate the speed? Okay, in that case, how we can calculate the speed? We have to go the 100 km, but we can't keep our speed the 50 km per hour constant, because there may be some crowded area sometimes. At that time, that particular area will have the distance of delta S, and for that, to cover that particular time, we need to cover that particular distance, we need the time period of delta T. And it may be happen that rather than reducing the speed, if there is the no crowded area, the road is blank, then in that case we may get with the higher speed, like the 60 km, 70 km, 80 km. In that case, we may travel with a higher speed. Okay, so there may be some area in which there is crowded space. So in that area, we have to travel with a reduced speed, like the 40 km, 30 km, 10 km per hour. And there may be some area at which the roads will be the blank. So in that case, we may travel with the higher speed than the 50 km per hour. We may travel with the 60 km per hour, 70 km per hour, 80 km per hour. Okay, so when in that case we have to calculate the speed, then how can we calculate the speed for this total between the two distance? Okay, how can we calculate the speed for that points between the two distances? Okay, so if we have to calculate the distance between the point A and the point B, and for this, if we have to calculate the average speed, then how can we calculate? So for that purpose, we have to take the summation of all such a small distances and the summation of all such as time intervals. Okay, we have to take the summation of all such a small distances and summation of all such a small time intervals. Then we will get the speed, and that speed is not the speed, but it is the average speed. Okay, it is the average speed. So how can we calculate the average speed? Average speed is equal to such a delta S1 plus delta S2 plus delta S3 plus up to dash dash up to plus delta Sn upon delta T1 plus delta T2 plus delta T3 plus 2 delta Tn, or we can write it as the summation of n is equal to 1 to n for the delta S upon summation of n is equal to 1 to n for the delta t. Okay, we have the formula for the average speed as delta S upon the delta t. Delta S upon the delta t. But this is the delta t. This is the small time interval. So if we have to consider the small time interval, so how much small time interval we have to consider? Okay, suppose we are counting the speed of the rocket. Okay, we are counting the speed of the rocket. Then in that case, we have to consider a very small time interval. We have to look at the speed of the rocket, how it goes on increasing for the very small time interval. Then in that case, we may go for the 0.1 second also. For the time interval of 0.1 second, how much is the speed? For the time interval of 0.2 second, how much will be the speed? For the interval of 0.3 second, how much will be the speed? So after the 0.1 second, how much will be the speed of the rocket, and how that speed of the rocket will get increased from the time interval 0.1 to the 1 minute. Okay, 0.1 to the 1 second. So in that case, we are having all the values from the 0.1 second also, for the 0.2 second also. So if we want the value of the speed at the 0.15 second, so can we calculate? Can we calculate the value of the speed for the 0.15 second, for the 0.25 second, for the 0.28 second, for the 0.32 second? Yes, we can calculate, because we have the value of the speed of the rocket and we have the value of the time. Okay, so we can calculate the distance there. How much will be the distance covered by the rocket during that small time interval? Okay, and such a small time interval we have to consider, so that we can get up to the actual value of the speed, actual value of the distance covered by that particular rocket. Okay, we have to take a very small time interval, less than the 0.1 second also, so that we can reach up to the actual value of the distance covered by that rocket and actual value of the speed of the rocket for that time interval. And such a time interval is known as the instant time. Okay, such a time interval which we have to consider a very small, just like it is approaching to 0. Okay, it is approaching to 0. Suppose if we consider the time interval, if delta t is approaching to 0, then it is the instantaneous time. Okay, it is the instantaneous time. And if we know the speed of the rocket for such a small time interval, that the time interval is actually approaching to the 0, then that speed of the rocket is known as the instantaneous speed. Okay, so instantaneous speed we can give as instantaneous speed is equal to limit delta t tends to 0 upon delta S upon delta t. So we are taking here the delta S upon the delta t approaching to 0, so we can write it as the ds upon dt. Okay, we can write it here as the ds upon dt. Okay, as we are considering the time interval almost approaching to 0, so that we can get the instantaneous speed, and to calculate that instantaneous speed we can write it also as the ds upon dt, where dt is the time interval for a very small time, almost approaching to 0. Okay, almost approaching to 0, then in that case such a type of speed is known as the instantaneous speed. And how to calculate the average speed? How to calculate the average speed? For the calculation of average speed, we have to consider the each and every smaller distance and the time interval for that particular smaller distance. Okay, we have the number of such a smaller distance and the time interval of such a smaller distances, then we can go for the average speed. We can go for the average speed because even if you see the speedometer, okay, if you see the speedometer, if you go in a crowded area and you reduce your accelerator, then in that case the speedometer shows the low speed. Okay, the hand of the speedometer will come down, it will show the low speed, but when you are on a blank road, then in that case when you increase your accelerator, your speed will get increased. Okay, your speed will get increased. Unless you keep your accelerator as it is, that hand of the speedometer will keep on moving. It will low, it will high, it will low, it will high, it will low, it will high. So why? Because you are not keeping your speed constant. You are not always going by the speed of 50 km per hour. You are not going always with the speed of 60 km per hour, but there is the variation of the speed. So if we are having the variations of the speed, then we have to consider for how much distance we are going with the how much speed, and for the how much time interval we are traveling with that particular speed. And for calculating the average speed, we have to consider such all the smaller distances and their respective time interval. Then we will calculate the average speed as the delta S upon delta T. Okay, we can calculate this by delta S upon delta T. So once we have all these values, we can go for the average speed. And if we want to calculate the instantaneous speed of any rocket, then we have to consider the time interval almost approaching to 0. Okay, almost approaching to 0. So that's why we can put their limit, that limit delta T tends to 0. It is delta S upon delta T, where the delta T we can write it as the dt and our distance will be ds. The respective distance will be ds. So like this way we can calculate the average speed of any object or the average speed of instantaneous speed of any object. Okay, suppose we have one vehicle, it is traveling, it has to travel 80 km per hour, and for it is taking the time of 2 hours. Then how much will be the speed? Okay, how much will be the speed? How can we calculate this? Okay, we have to go here 80 km we have to go, and the time interval is 2 hours. But for the time interval, during this time interval, it is not going with the constant speed. It is not going with our calculated speed. How can we calculate here speed? Here speed is equal to 80 km upon 2 hours. So it will be 40 km per hour. Okay, this is the recommended speed. But during these 2 stations, there are lot many interruptions, there are lot many distractions. So sometimes it has to reduce its speed, sometimes it has to increase its speed, and it is not going with a constant speed. Then in that case we have to consider its average speed. So let us suppose that it is having the instance S1, S2, S3 be the interval of distances. Okay, interval of distances, and T1, T2, T3 be the respective time interval. Okay, be the respective time interval. Then how can we calculate the average speed? How can we calculate the average speed here? So here we have to take that. We know how can we go for the speed. How much will be the speed for that particular time interval? How can we calculate? Suppose here is the V1 for the first interval, then it will be S1 upon T1. The V2 will be equal to S2 upon T2. V3 equal to S3 upon T3. Okay. S1 upon T1, S2 upon T2, V3 equal to S3 upon T3. Then how can we calculate the average speed here? What is the procedure to calculate the average speed? So for that purpose we can go by the using the direct formula of average speed, as the V average equal to S1 plus S2 plus S3 upon T1 plus T2 plus T3. Okay. Or we can write it down as, what is the S1 from this equation? S1 is equal to V1 T1 plus V2 T2 plus V3 T3 upon T1 plus T2 plus T3. Or we can write down it as the S1 plus S2 plus S3 upon, what is the T1 from this equation? T1 is equal to S1 upon V1 plus S2 upon V2 plus S3 upon V3. Okay. We have these two equations. Either we can go by this equation, or either we can go by this equation. Okay. So V average we can calculate as V1 T1 plus V2 T2 plus V3 T upon T1 plus T2 plus T3. Or we can convert the time. Okay. Time equal to S1 upon V1. So we can write it S1 plus S2 plus S3 upon S1 upon V1 plus S2 upon V2 plus S3 upon V3. Okay. These steps we can follow if we know the particular time interval, then we can go by this step. If we know the particular distance interval, we can go by this step. Okay. So this equation is for the knowing the time interval. And this equation is for knowing the distance interval. If the time interval is known, we can go by this formula, and if the distance interval is known, we can go by this formula. Okay. So we will take one small example on these average speed calculations, so that you will get the idea how can we apply this to actual numerical. In the numerical parts, there are specifically two types of numericals are there. So in which, in first case, there may be some equal time intervals. Then in that case, we have to convert this equation. Okay, we have to convert this equation into the form of this. Okay, and when we have the problem like the equal small distances, then we have to convert our equation into this form. Okay, so let us see one example on this. That a car is traveling with a speed of 60 km per hour for the first 1 hour, and the 40 km per hour for the second hour. That is, for the first hour, for 1 hour it is traveling with 60 km per hour, and for the second 1 hour it is traveling with the 40 km per hour. Okay. So how much will be the average speed of that car? Okay, how much will be the average speed? So how can we calculate the average speed? We know here we can go, we have the distance. Okay, we have the distances 60 and the 40, we have the time interval 1 plus 1, so that we can get average speed is equal to 60 plus 40. This is the distance covered upon 1 plus 1. This is the time interval, so that 100 upon 2, it will be 50 kilometer per hour. Okay, it will be 50 kilometer per hour. But if we take it like the one numerical, then in algebraic form we can form one equation for such type of examples. When we have equal time interval t for velocities, for varying speeds or speeds v1, v2, v3 up to v suffix n, then how to calculate the v average? Okay, how to calculate the v average? We have the equal time interval. We don't know about the distance. We have the equal time interval. Then in that case, we have to convert our equation of the average velocity in terms of the time. So we can write here as v1 into t plus v2 into t plus v3 into t plus 2v suffix n into t upon t plus t plus t plus up to t suffix n. Okay, up to t suffix n. So we can write it here same here as t into bracket v1 plus v2 plus v3 plus up to v suffix n upon n into t. N times t we have to consider here. Okay, n times t we have to consider here. So our v average will be t into bracket v1 plus v2 plus v3 up to v suffix n upon n into t. So this t will get cancelled here. So we can write down here v1 v1 plus v2 plus v3 plus up to v suffix n upon n, where n is the number of intervals given. Okay, n is the number of intervals given, or we can write here as summation of n is equal to 1 to n for the v upon n. Okay, v average when we have given the equal time intervals and respective their velocities. Okay, so we can go by this equation. We have to consider, even if we consider this equation in this case, okay, in this case if we consider this equation, then we will get v average equal to summation of v, that is 60 plus 40 upon number of time intervals 2. Okay, so 60 plus 40 upon 2, it will give us the 50. Okay, it will give us the 50. Suppose if we solve this example with this formula, then we will get summation of v, it is 60 plus 40 upon number of intervals given. For first it is 60, for second it is 40, so we will take the two intervals are there, so 100 upon 2, it will give the 50 kilometer per hour. Okay, it will be 50 kilometer per hour. Okay, so like this, if the time intervals given are same, then we can use this formula. This is the one algebraic form, and this is the one type of example can come on the average speed. Okay, this type of example can come on the average speed where the equal time interval is given. Now the second case is when the equal distances are given. Okay, so for the second we will consider how to calculate the average speed when the equal distance is given, not the time interval, equal distance intervals are given. So in that case, suppose a car is traveling the first 100 kilometers with the 60 km per hour and the next 100 kilometers with the 40 km per hour, then how to calculate the average speed? Okay, so the first 100 km is traveling with the 60 km per hour, it is the velocity, and the next 100 km with the 40 km per hour velocity. Okay, so in that case, how to calculate the average speed? How can we calculate the average speed? We know what is the formula of the average velocity. It is average speed is equal to, how much is the distance covered? It is 100 plus 100. And what is the time? What is the time here? We don't know the time. So what is the time? Time is equal to, velocity is equal to, speed is equal to distance upon time. So what is the time? Time is equal to distance upon speed. Okay, so it will be 100 upon 60 plus 100 upon 40. So it will come as 200 upon, how much it is? It will be, if we take the LCM of this, it will be the 60 into 100, it will be 600 plus 40 into 100, it will be 400 upon this 60 into 40, that is 2400. So it will be 200 upon, it is 10,000 upon 2400. Okay, so our equation will be average speed will come as 4800 upon 100 is equal to 48 km per hour. Okay, it will be 48 km per hour. Okay, it will be 48 km per hour. Now, if we make one algebraic equation of this, then we have to consider the number of time intervals, and accordingly we have to go for the further equations. Okay, if the number of time intervals are for equal distance intervals, as if we have the speeds as V1, V2, V3 up to V suffix n, then we can write as, how can we write this? That S is equal to, or you can write this, that T1 is equal to S upon V1, T2 is equal to S upon V2, T3 is equal to S upon V3 up to T suffix n is equal to S upon Vn. Okay, so like this way we can calculate the time for that particular interval of distances. So how to write the V average? V average, it is equal to some S plus, okay, we can write it as S plus S plus S plus up to S suffix n upon S upon V1 plus S upon V2 plus S upon V3 plus up to S suffix V suffix n. Okay, you can write it as S into n upon S into bracket 1 upon V1 plus 1 upon V2 plus up to V 1 upon V upon N. Okay, so we can write down it as, what is the formula here? That N upon 1 upon V1 plus 1 upon V2 plus up to 1 upon V suffix N. Okay, so V average, we can calculate this by this formula. Okay, we can calculate the V average by using this formula when we have the equal distance intervals. Okay, we can calculate this by using the equal distance intervals. Okay, suppose we calculate this given equation by this formula, then we will get, what is the value of N here? 2 intervals upon 1 upon 60 plus 1 upon 40, so that we can get it 2 into 2400 upon, what is the formula here? 60, 40 plus 60, so we get 4800 upon 100, so it will be 48. Okay, it will be 48 kilometer per hour. So this is the average speed when we use this formula. Okay, so this is the one very simple formula. You don't have to go for this such a large values here. Okay, you have to consider here the 100 upon 60, 100 upon 60, then take its LCM, and you have to divide such a big numbers here. You have to make the operations on such a big numbers. So instead of that, you can use this formula and you can solve this equation by using this formula. Okay, we have seen how we are getting this value. Number of intervals 2 are given here, then 1 upon V1 it is 60 plus 1 upon V2 it is 40. So we have solved this 2 into its LCM, that is 2400 upon 40 plus 60, then 4800 upon 100, you will give us the 48 kilometer per hour. So we have to see one more example here, that a body traveling in a straight line traveled 1/3 distance, okay, with a velocity of 4 meter per second square. Okay, out of the total distance, the 1/3 distance is covered with a velocity of 4 meter per second. The remaining part of the distance was covered with a velocity of 2 meter per second for the half time and 6 meter per second for the second half time. Okay, out of the total time, for the first half time of the remaining, then the 1/3 it is traveling with 2 meter per second, and for the remaining half time it is traveling with 6 meter per second. What is the mean velocity average over whole time of the motion? Okay, we have to calculate here the average velocity. Okay, so let us see how to calculate the average velocity in such a combined numerical. Okay, so for this purpose we have to consider that the total distance traveled or the total distance covered is the thrice s. Okay, because that thrice s will be convenient to us, because 3 parts are given here, the 3 intervals are given here, and if we consider the distance in terms of the multiple of 3, then it will be easy one for us to go for the further calculations. Okay, so let total distance be thrice s. Okay, total distance be thrice s. If I write down this here, then we will get, if I show you here, this is the total distance, which is a thrice s, and this is the thrice s. Out of this thrice s distance, what is given, that the 1/3 distance is covered with the velocity of 4 meter per second. Okay, 1/3 of the thrice s will be the s. So out of this total distance, the s distance, the 1/3 of thrice. Okay, this distance is 1/3 of thrice, means 1/3 of 3s, that is the equal to s. So one third of distance is covered with the velocity of 4 meter per second. Okay, v is equal to 4 meter per second. Now the remaining part of the distance was covered with the velocity of 2 meter per second for the half time and for 6 meter per second for the second half time. So if we make the two intervals of the time here, okay, so with respect to a two interval of time, our here will be the S2 equal to how much it is coming? It is equal to having the velocity of 2 meter per second. Okay, then here will be the S3. So can we calculate the S2 and S3? Can we calculate the S2 and S3? We have the time T2 for the T2 equal to, we have the time T2 equal to, have the velocity equal to 2 meter per second. 2 equal to, for T2 V2 equal to 2 meter per second. So respective S2 will be equal to, how to calculate the distance? Distance is equal to velocity speed into the time, so it will be twice t. Okay, the v into t2, so it will be v2 into t2, so it will be twice 2. And similarly for the t3, v3 equal to 6 meter per second, so S3 equal to v3 into t3, so it will be equal to 6t. Okay, it will be equal to 6t. So we can write down it here that S2 equal to 2t and S3 equal to 6t. Now from this equation, can we calculate the value of the t? Okay, from that equation, can we calculate the value of the t? Okay, from first interval, t is equal to, what is t is equal to? Distance upon velocity, so it will be s upon 4. Okay, if we put the t is equal to s upon 4 in this equation, we will get s2 is equal to, t is equal to s upon 4, 2 into s upon 4, so it will be s2 is equal to s upon 2, and s3 is equal to 6 into s upon 4, so s3 is equal to thrice s upon 2. Okay, now we have the value of the s1. How much is the s1? s1 is equal to s. Okay, s1 is equal to s, s2 is equal to s upon 2, s3 is equal to thrice s upon 2. So we have the values of the distances, and from that values we can go for the time interval t. Okay, so from the first equation we can solve t is equal to, what is s upon v. Okay, s upon v is equal to, what is the t? Is equal to s upon s1 upon v. S1 is s, so v is the 4 meter per second. So for this, from this we can write down that t is equal to, we have s2 is equal to twice t, so t is equal to s2 upon 2, so it will be equal to s2 is s upon 2 upon 2, that is the s upon 4. Okay, t is equal to s upon 4. Now for this we can write that t is equal to s3 upon 2, so it will be equal to thrice s upon 2 upon 2, so it will be equal to 60 is equal to, okay, into 6. Okay, so t is equal to s upon 4. Okay, so if we look at this, we come to know that we are having the same time intervals here. Okay, we have the same time intervals here, so we can use our formula of the average velocity. V average is equal to summation of all the distances, it is total distances we have considered 3s upon this total time intervals, that is t1 plus t2 plus t3 and is equal to thrice s upon 3 into s upon 4. Okay, so we can write down here as s will also get cancelled, so we can write here 4 meter per second. Okay, this is the average speed during that total time interval from the distance of 3s. Okay, so this is the answer of our question. Okay, for the first time interval we have considered that it is having total distance of 3s, and accordingly we have solved that for the first 1/3 distance it is having the velocity of 4 meter per second. Accordingly we have considered the s1 that is equal to thrice 1/3 of 3s, that is the s1. So s1 is equal to s, so we can write here for the velocity of 4 meter per second the distance covered is s. Then for the remaining, it is the for the time is given, and for that time interval of the we have the velocity of 2 meter per second, and for the next half time interval we have the velocity of 6 meter per second. So accordingly we have written the equations for the distance, that is s2 is equal to twice t, and for s3 is equal to 6t. Okay, so then s2 is equal to 2 into s upon 4. Why? Because we got here t is equal to, from the first time interval we get the value of t, that the t is equal to s upon 4. Okay, from the first time interval t is equal to s upon 4. If we put this value in this equation, we get s2 is equal to s upon 2. And similarly we put this value in the s3, so that we will get s3 is equal to 6 into s upon 4. We will get the thrice s upon 2. Okay, now from this equation if we calculate the value of t, then by using the formula speed is equal to distance upon time, that is the time is equal to distance upon speed, we have the speed that is 4 meter per second. So from that we get st is equal to s upon 4. Okay, now we put this value of t in this equation. Then from this, how much is the time interval for this distance of s upon 2? We have to calculate. Then s upon 2, okay, s2 is upon 2, it will be the 2 will be the velocity or the speed. So s2 is equal to s upon 2, we put here s upon 2 upon 2, so t is equal to s upon 4. Then for the next interval we have considered that 60 is equal to s3 upon 2. 60 is equal to s3 upon 2. Then in that case, what is the s3? s3 is equal to thrice s upon 2, and from that t is equal to, we get s upon 4. So as all the time intervals are same, we can put down this value in our average speed equation, that is v average equal to thrice s upon t1 plus t2 plus t3 is equal to thrice s upon 3 into s upon 4, that is 4 meter per second. Okay, this is the value of the final average speed. Okay, so these are the some numericals which may be asked on the average speed. Okay, so whenever we have to change our location from one point to another, we have to change our time interval also. So what is the speed? Speed is the distance covered during that time interval. And if for that time interval, if our speed is uniform throughout that continuous time interval, suppose we are traveling 100 km and we have divided that 100 km into 5 parts of 20, 20, 20, 20, then in that case, for the first 20 km, if we are traveling with the 40 km, for the second also we are traveling with the 40 km, for the third also we are traveling with the 40 km, and for the fourth and fifth also we are traveling with the 40 km per hour, then our speed is uniform there. Okay, that type of speed is called as the uniform speed. And if we are traveling with the variations in the speed for the different time intervals, then that type of speed is known as the non-uniform speed. Okay, so that part also we have to study in brief in the next lectures.